Welcome to our deep dive today into the world of room temperature superconductors. You're here because you want to understand this potentially revolutionary technology, and it's clear to see why. We were talking possibilities like abundant energy, super fast computers, and even maglev trains.
Right.
But before we get too ahead of ourselves with all the possibilities, let's actually break down, like what superconductivity even is.
Yeah. So it's this phenomenon that's kind of captivated scientists for over a century now. Way back in 1911, they actually discovered that some materials could conduct electricity with absolutely no resistance. But the catch was that this only happened at extremely low temperatures.
Oh.
So that's the catch that scientists and researchers have been kind of grappling with ever since.
So what you're saying is it's like this incredible potential, but it only works when it's practically impossible, to make it work.
Exactly. But just imagine, though, a power grid that had no energy loss during transmission. I mean, that's just one of the incredible things that we're talking about here.
Okay, so no resistance at all. That's that's pretty mind-blowing.
Right.
Yeah. Is there anything else that makes superconductors so special?
Well, yeah, they also exhibit something called the Meissner effect, which essentially means they can, expel magnetic fields. So this causes magnets to actually levitate above them, which is a pretty wild visual.
Really?
Yeah, you can actually see them floating. But the holy grail of this whole field has been trying to find these materials that exhibit these properties, but at room temperature. And that would open up a whole new world of applications.
So right now it's just in the lab and we're just kind of observing this interesting thing. But once we can actually, get it to room temperature, then we can actually start using it.
Then the possibilities become endless.
Okay. I'm starting to see now why this is such a big deal.
Yeah.
But I remember hearing about LK99 last year. It was this material that supposedly, they were saying that it had achieved room temperature superconductivity. What happened with that?
Yeah, so LK99, it created quite a buzz for sure. But the initial excitement kind of quickly faded, unfortunately. It turned out that what they were actually observing was probably due to something called ferromagnetism. So basically a really strong permanent magnet.
Oh.
Which is not the same as the zero resistance state of a true superconductor.
Right. So it kind of looked like it, but it wasn't actually what we were looking for.
Exactly.
Okay.
Yeah, and other scientists couldn't replicate those initial findings, so the hype eventually died down.
Yeah.
But, it's a good reminder, though, that even in science, things aren't always what they seem.
Yeah, I guess a good dose of skepticism is always a good idea, especially when something seems a little bit, too good to be true. But if it's so challenging to achieve this room temperature superconductivity, what are researchers focusing on right now? What are they working on?
Well, one area that's getting a lot of interest is something called high-pressure hydrides. So these are hydrogen-rich materials that when they're put under incredibly high pressures, they can exhibit this superconducting behavior, but at temperatures much higher than the traditional superconductors.
Okay.
Yeah.
So it's squeezing these materials is actually the key.
Yeah.
I'm curious, how does applying all that pressure, what does it actually do to the material, on an atomic level?
Okay, so think of it this way. When you squeeze atoms closer together under a ton of pressure, you're essentially forcing their electrons to interact a little differently.
Okay.
Yeah. So in the case of these hydrides, the pressure kind of mimics the behavior of metallic hydrogen, which is theorized to be a superconductor, but at high temperatures. So we're kind of trying to recreate those extreme conditions in the lab.
Right. So we're taking something that happens in nature, but deep down in the earth or something like that. Trying to recreate that in the lab.
Right.
Okay. So high pressure creates a sort of simulated environment for the superconductivity. It makes sense. But how do scientists even create that kind of pressure in a lab? How do they get it that high?
So they use something called a diamond anvil cell, which is basically two perfectly cut diamonds that press this tiny sample of material between them. And then using lasers, they can actually heat the sample up.
Oh, wow.
While maintaining that super high pressure. It's a pretty sophisticated setup.
It sounds incredibly delicate. You're talking about these tiny little diamonds and lasers. Well, I imagine working with these materials must be a huge challenge.
It is, yeah. Just creating and maintaining those extreme pressures is a feat in itself. And then you have the issue of stability. These materials are often very finicky, and they can decompose really easily if the pressure isn't carefully controlled.
And I'm guessing that once the pressure is released, they go back to their, non-superconducting state.
Exactly. Yeah. So this makes studying them in detail incredibly difficult,
Yeah.
let alone trying to actually use them in practical applications.
Yeah. So it seems like high-pressure hydrides, while promising, they have some serious limitations when it comes to actually using them in the real world.
Right.
So are there any other approaches that scientists are exploring that wouldn't require such extreme conditions?
Yeah, there are actually quite a few.
Okay.
Researchers are looking at things like, manipulating the crystal structure of materials, doping them with impurities to change their electronic properties, and even creating entirely new types of superconducting materials.
Wow.
So, for example, carbon-based materials like graphene and nickelates have shown some potential for high-temperature superconductivity, but at more reasonable pressures.
Okay, so there's a lot of research happening beyond just squeezing things really, really hard.
Exactly.
But,
Yeah, it's a multi-pronged approach.
but I'm still curious about what are the specific benefits that make room temperature superconductors so desirable? Like, what can we actually do with them?
Okay, well, imagine a world where we could transmit electricity across vast distances, but with no energy loss.
Hmm.
I mean, that's what room temperature superconductors could enable. We could revolutionize our power grids,
Right.
making them vastly more efficient and reducing our reliance on fossil fuels. It'd be a huge step towards, combating climate change and achieving global energy sustainability.
Yeah. That's a powerful image. A world running on super efficient energy.
Right.
What about the impact on technology? Like, would our computers and our phones become, like, super powered?
Yeah, prepare to have your mind blown.
Okay.
Room temperature superconductors could lead to computers thousands of times faster than what we have today, but they'd use like a fraction of the energy. We're talking about ultra-fast processing, more powerful electronics, and like incredibly long battery life.
Okay, I'm officially hooked. What about other areas like transportation and healthcare? Could room temperature superconductors revolutionize those fields as well?
Absolutely. Imagine super efficient maglev trains levitating above the tracks and zipping around at incredible speeds.
Wow.
I mean, it would revolutionize travel and transportation. And then in medicine, we could have more powerful and affordable MRI machines, leading to earlier and more accurate diagnoses. I mean, the possibilities are really endless.
It sounds like we're on the verge of like a technological utopia.
Right.
But I imagine there might be some downsides too. I mean, such a powerful technology could have some unintended consequences.
You're right. As with any powerful technology, there are potential risks. It's important to consider the ethical implications, potential economic disruptions, and environmental concerns that might arise.
So it's not all sunshine and rainbows.
Right.
We need to be cautious and plan for the potential pitfalls. But for now, let's dive back into some of the more recent discoveries and controversies surrounding room temperature superconductors. I've heard about this material called carbonaceous sulfur hydride. What's the story there?
Yeah. So carbonaceous sulfur hydride definitely had its moment in the spotlight. Back in 2020, a research team claimed they had observed room temperature superconductivity in this material.
Okay.
But there was a catch. Yeah, the catch was that they achieved this supposed superconductivity at a pressure of 267 gigapascals, which is about the same pressure you would find, like deep within the Earth's mantle.
Wow, that's some serious squeezing.
Mm-hmm.
So not exactly something you could easily replicate in a practical setting.
Right. And while the initial findings, they generated a lot of excitement, there was also a lot of scrutiny from the scientific community. Yeah, there were concerns about the reproducibility of the results, and of course, those incredibly high pressure requirements led to some healthy skepticism.
Right.
And in fact, the paper that reported those findings was later retracted.
Oh, wow. So was that controversial?
Yeah, it was a big deal.
It seems like the scientific process is a bit like a roller coaster ride sometimes, full of ups and downs and unexpected twists.
It totally is. But, these setbacks and controversies are all part of the journey. They often lead to more rigorous, research-improved experimental techniques and ultimately a deeper understanding of the phenomena that we're studying.
So even though carbonaceous sulfur hydride didn't quite pan out as initially hoped, it probably pushed the field forward in some way.
Definitely. It sparked important discussions about the challenges of working with these high-pressure materials and highlighted the need for independent verification of results. And it also underscored, the ongoing search for materials that exhibit room temperature superconductivity at more reasonable pressures.
It's fascinating how this quest for room temperature superconductivity isn't just about the science itself.
Right.
It's also kind of a human story filled with excitement and disappointment and, this relentless pursuit of knowledge.
It really is, yeah. It speaks to our deep-seated curiosity and our desire to just understand the universe around us.
Let's shift gears a bit and talk about the potential impact of this technology. We've touched on some of the exciting possibilities, but what would a world powered by room temperature superconductors actually look like?
Well, imagine a world where energy is abundant and readily available to everyone. With superconducting power grids, we could transmit electricity across vast distances with virtually no loss. I mean, this would revolutionize our energy infrastructure, reducing our dependence on fossil fuels and really making clean energy a reality for everyone.
It's amazing to think about the positive ripple effects this could have on climate change and global energy sustainability. What are the impact on technology? How would our everyday lives be transformed?
Well, think about all the devices we use every day. Our smartphones, our laptops, and even electric vehicles could become, significantly more powerful and energy efficient. We could see these breakthroughs in computing power, data storage, and battery life that would completely transform how we live, work, and interact with the world around us.
It sounds like we're talking about a whole new era of technological advancement.
It would be incredible.
But what about the potential downsides? I mean, we can't ignore the possibility of some unintended consequences.
You're right. It's important to consider the ethical implications of such a transformative technology. Will everyone have equitable access to these advancements? Could there be economic disruptions? Or even, potential misuse for harmful purposes? These are all questions we need to grapple with as this technology evolves.
So it's not just about the scientific breakthroughs, it's about navigating the societal and ethical challenges that come with them.
Exactly, yeah. Responsible development and, thoughtful consideration of the potential impacts are crucial to ensure that this technology benefits all of humanity.
Okay, so we've talked about the potential benefits and risks, but let's get practical for a moment. Even if we manage to crack the code of room temperature superconductivity, how do we actually scale this up from a laboratory setting to real-world applications?
Well, that's where the fields of engineering and manufacturing come into play. Right now, many of the materials that show promise are incredibly difficult and expensive to synthesize. They often require really specialized equipment and controlled environments.
So it's not just about understanding the science, it's about figuring out how to mass produce these materials efficiently and cost effectively.
Exactly. We need to develop new manufacturing processes and techniques that can produce these materials on a large scale while maintaining their purity and stability. It's a challenge that requires collaboration between scientists, engineers, and manufacturers.
Sounds like a massive undertaking.
It is.
But the potential rewards are immense.
Indeed. It's a testament to human ingenuity and our drive to overcome seemingly insurmountable challenges.
So while we might not have room temperature superconductors powering our homes just yet, the pursuit itself is driving incredible innovation and pushing the boundaries of what's possible.
Absolutely. And who knows, maybe someday instead of marveling at levitating magnets in a lab, we'll be commuting on super-fast maglev trains, all thanks to the magic of room temperature superconductivity.
That's a future I would love to see. But for now, let's shift our focus to the cutting-edge research and development efforts that are shaping the future of this field. What are some of the latest tools and techniques that scientists are using to unlock the secrets of room temperature superconductivity? It seems like the hunt for room temperature superconductors is this truly interdisciplinary effort.
It is, yeah.
I've even heard that computer modeling and AI are playing a role now. Is it really possible for computers to help us, discover new superconductors?
Oh, it's not just possible, it's becoming, essential. Computational modeling has totally revolutionized material science. Researchers are using these incredibly detailed simulations to predict how materials will behave under, those extreme conditions, like those high pressures we've been talking about.
Right.
So they can virtually test tons of different combinations of elements and structures, looking for those telltale signs of superconductivity. And they can do all this, before even setting foot in a lab.
So it's like a virtual laboratory letting scientists experiment without the constraints of the physical world.
Yep, exactly.
That sounds incredibly powerful.
It is, and artificial intelligence is actually adding another layer of sophistication now.
Really?
Yeah. So machine learning algorithms can analyze these massive data sets of material properties, looking for patterns and correlations that humans might miss. And this can help, pinpoint promising candidates for room temperature superconductivity much faster and more efficiently.
It's amazing to think that we're using computers to help us understand the fundamental building blocks of matter.
I know, it's pretty wild.
But it's not all happening in the virtual world, right? What kind of advancements are we seeing in actual lab settings?
Oh, yeah. Labs around the world are definitely pushing the boundaries of what's possible. Researchers are using, advanced laser systems to create these incredibly high pressures in those diamond anvil cells, allowing them to explore material properties at pressures that have never been achieved before. And then they're also using synchrotron radiation, which is this powerful type of X-ray, to observe the atomic structure of materials in real time. And this gives them, those valuable insights into the actual mechanisms behind superconductivity.
It's incredible how technology is driving scientific exploration.
Yeah.
But let's zoom out a bit and talk about the bigger picture. Even if we do achieve room temperature superconductivity,
hmm
how do we go from that scientific breakthrough to actually using this technology, in the real world?
That's where the real challenge lies. One of the biggest hurdles is scalability. Right now, a lot of these promising materials are extremely difficult and expensive to synthesize, and they often require very specialized equipment.
Right.
We need to figure out how to produce them on an industrial scale, efficiently and cost effectively.
Right. So it's not just about making a tiny sample in the lab. We need to be able to produce tons of this stuff.
Exactly. Yeah, and then there's the question of how to actually integrate these materials into existing technologies and infrastructure.
Right.
I mean, just imagine trying to retrofit our entire power grid with superconducting wires. It's a monumental task that would require significant innovation and investment.
It sounds like the transition to a world powered by room temperature superconductors would be this complex and multifaceted journey involving not just scientific breakthroughs, but also advancements in engineering and manufacturing and global infrastructure.
You got it. It's a long-term endeavor that will require sustained effort and collaboration across many different disciplines. But the potential benefits are so significant that it's a journey worth taking.
It's a testament to human ingenuity and our unwavering belief in progress.
Right.
Even though the path may be long and challenging, the vision of a future powered by room temperature superconductors is truly inspiring.
It is. This quest has captivated, the imaginations of scientists and engineers for over a century. And while we may not have all the answers just yet, the journey itself is a testament to the power of human curiosity and our unwavering belief in the transformative power of science and technology.
Well, that was a truly electrifying deep dive into the world of room temperature superconductors.
Yeah, it was fun.
We've covered a lot of ground today, from the fundamental science to the potential impacts and the challenges that lie ahead. You should now have, a solid understanding of this fascinating field and be ready to follow its progress with informed curiosity.
It's been a pleasure sharing this journey of discovery with you. Remember, the quest for room temperature superconductors is far from over. New discoveries and breakthroughs are happening all the time, so stay tuned and keep exploring.
That's a great reminder. And if you enjoyed this deep dive, be sure to like and subscribe to 15-Minute Discourse for more insightful explorations into the world's most fascinating topics. Until next time, keep those minds curious and those imaginations ignited.